All right, this is group four presentation on VR enhancement. My name is Daniel Chin, and I'm a major in UX design in Polytech School. My picture is all the way to the left.
Hello, I'm Drew Gregory. I am a major in virtual product integration at the Polytechnic School, and I am the picture second from the left.
Hi, I'm Zungding. I'm majoring in CNIT and I'm next to Drew.
Hi, my name is Samir Prasad and I'm majoring in cybersecurity and I'm the picture to the far right.
So for our credibility, we conducted a lot of interviews, observations, and used a lot of literary sources to gather the knowledge that we needed for this global challenge. For our interviews, we conducted a lot of questions on students and other professionals who have used VR. We wanted to use interviewing questions that would create a non-biased answer, um, and that would create a solution for us to see the underlying issues other than the obvious.
For observations, we observe people's natural reactions while using VR. We also observe that people need too many things in order to experience VR to its fullest.
Regarding the source, we have machine learning, different type of VR, different prices, and people experience, and publication and research.
When it comes to the grand challenge of VR, the overall challenge is enhancing VR for the future goal of dangerous training and other helpful uses that cannot be limited to that. So, our goal, the reason why we picked this is we want to manage to improve this challenge and make it easier to come to that end goal.
Our stakeholders are current VR users, people wanting to experience new technology with full immersion, gaming industry, and industrial development and research.
Some constraints of the stakeholders are the bulkyness, the audio, and VR can induce sickness, and the cost of the headset.
When we researched, we found out that VR is usually hard to carry around because of its bulky size, and sometimes the straps are too loose on the headset, causing it to slowly slide down the face. We also found out that audio was especially lacking in creating a feel from the real world.
So, current existing solutions, there are two that we found that were the most effective. And the first one's a white noise device. And this does drown out noise by creating more noise. So, that's the weakness of it. And meanwhile, something that's similar to our solution is noise canceling headphones, which they can cancel out the noise, but it has the burden of having to wear it.
Our proposed solution is a device which has a speaker to send out noise cancelling frequency, a microphone to listen to room noise, a case for the mic and speaker, and an internal chip and software.
All right. So for our proposed solution, I have visual elements that can demonstrate how we want this to work. So for noise cancellation, we have an image here. This would be our input noise. And if we take a exact copy of that and invert the colors, that represents the inverse sound that would be playing out of our device. And if we turn the opacity to 50%, so you can see through it, and we place it on top of the original image, you can see that it cancels it out completely. There are no colors and there's no depth. There's a solid gray color, which signifies the cancellation of the color or the noise. So it just cancels out completely. We also have a more typical visualization. You have the initial sound wave. That would be the noise coming from the room. And if we duplicate that and have it red, so it's the exact same wave, and we just flip it upside down over the x-axis, we can see that as this wave goes up, this wave goes down, effectively canceling out any frequencies and allowing for a straight bar across the top and bottom, and resulting in no noise being perceived by the human ear.
So for our constraints and criteria, the main two we're focused on is cost and reliability. So we wanted something that is cost efficient and costs within $50 of current existing VR products and headsets. So our prototype ended up being $10 to $20. And then reliability, it's supposed to muffle the noise. Based on our testing, it can't fully cancel out the noise, but it will be able to cause a greater experience.
We think it's a viable solution because it solves a problem that there is currently no solution for. And the noise cancellation market is also growing in technology, so it's important to start implementing the technology. We think this will be a great success because this product will be obtainable due to its low cost of manufacturing and ease of use.
So for our design process, we sat down and created a bunch of unrestricted ideas. And then we took those ideas and categorized them into several different groupings. And we eventually narrowed it down to the 3 ideas you see on the right. We decided to continue with the room noise cancellation device after prototyping all 3 because we found it to be the most viable and the most effective at solving the problem that in our interviews. After we decided what we wanted to do, we took it to a drawing board and sketched it out. We have images of microphones, speakers inside of a housing, much like a Amazon Alexa or a Google Home Mini. So we wanted it to be very small, portable, and effective to be carry around any room in the house or wherever you want it. In the bottom, you can see our first physical mock-up is of a speaker and holes on the side so that the room noise could go inside and be detected by the chip and played in the inverse out the speaker.
So through Autodesk Fusion 360, we were able to create the housing for a Raspberry Pi, and the Raspberry Pi would contain the code of through Java. So we'd throw the Raspberry Pi as shown on the picture on the left. The coding is on the Raspberry Pi, which is displayed on the monitor, and the Raspberry Pi is also connected to the speaker, which could show the function of the sign cancellation.
Here we see the Raspberry Pi hooked up to the computer and a mouse, and it's just displaying on this monitor. So if we open up the code, you can see we can generate a sine wave. That is just an even tone. Now if we apply noise cancellation, there is no sound. We can take it off, and there is sound. We put back on, there's no sound.
When it comes to prototyping is definitely the most challenging problem because of the nature of noise canceling and the amount of time we have. Therefore, I program a simple sine noise canceling program in Java. This program generates sine and negative sine wave at the same time to cancel out each other, as shown in the picture below. Our test data only covers sine noise. We collect data by pressing the noise cancel button in the program. You can also click the light noise cancel to cancel out the noise partially, and it works as expected. However, that is a very simple program and it can only cancel out sine noise. So our solution successfully illustrate the noise canceling at the most basic level. As of right now, it cancels out a constant sound that has to be manually set up. You can see in the graph below, only work with sine noise and not any other noise.
Okay, so what are our next steps? What's our vision? So for our vision, we wanted to create a cohesive product that can be mass produced and available to a wide range of situations, not just virtual reality. It could be used for a noisy apartment or loud street noise. What needs to be done? We need a lot more research, a lot more software development. We need to know how to take an input noise and relay a reverse noise for that. We also want to implement AI and machine learning. So we need a lot more testing for that and a lot more research. What does the audience need to do? We want you guys to tell us the impacts this product would have on your everyday life and where it can be used.
All right, I would like to thank everyone for listening, and now we are getting into the live Q&A.